All right, so here's a quick little mini lesson on something called compound interest. So it's very similar to our lesson on growth and decay with one small change. We're going to add in one special little piece here, this value of n, and I'll explain that here in a minute. But the idea is, in a lot of the problems we've been doing, it's been over 6 years or over 10 years, but it just gets, that interest is calculated once a year. It gets added to the total, and then that new balance gets the interest added to it the following year. A lot of places like banks will do this more often, so sometimes they might do it every month or every day, where every time that interest is calculated, your balance is going up, and the more times it happens, the more frequent it happens, the quicker that balance can increase for you. So that n is going to be how often it is being compounded. Instead of just being done once a year, maybe it's done every month, so it's being done 12 times a year, or it's being done every quarter, so 4 times a year. So the 2 times where that's going to come in is, so for instance, in our first problem here, we have $50,000 for 6 years at 2.5% interest. Well, that 2.5% interest is for the whole year, but we're going to be compounding it semi-annually, which means twice a year. So you don't get the whole 2.5% every time they do it, you get it for the whole year. So we're going to take 2.5%, we're going to change it to a decimal, so 0.025, but since it's being done twice a year, we have to divide it in half, because you don't get that whole interest all at once. We're still going to add it to our 1, because we still want all 100% of the original amount. P is your principal balance. Think of your starting amount. And then T is still your time, in this case 6 years, but it's going to be calculated over 6 years, but it's going to be done twice a year for those 6 years. So we're going to do 2 times 6. So a total of 12 times that interest is going to be calculated. So our only changes are, we have to divide the interest by how many times it's being calculated. We're basically breaking it up over the course of the year. And then we're also multiplying the time by that number, because it's going to be calculated that many extra times over the course of the time. So now we plug it into our calculator. So I do 50,000, and then in parentheses I do 1 plus 0.025 divided by 2, and then I close my parentheses, and then my exponent is going to be 2 times 6. So I plug that into my calculator, and I get an answer of $58,037.73. So the only thing that's changing is we're dividing the rate by how many times it's being calculated during the year, and then we're multiplying the time by that same number, because it's being calculated that many extra times over that number of years. So go ahead and try the next 2 along with me. So we start with our initial amount, $400, and then we're going to do 1 plus, we're going to put in our rate, 6%. Remember, we changed that to a decimal, so 0.06, compounded monthly. So there's 12 months in a year, so I'm going to divide by 12. I divide by how many times it's being calculated. We're breaking that rate up over 12 months. My exponent is going to be the number of times it's being calculated, multiplied times how long it's going to be going. So it's going to be done 12 times a year for 3 years, so 12 times 3. So go ahead, plug that into your calculator. 400 times 1 plus 0.06 divided by 12. Remember, it's just the 0.6 that's being divided by 12, not the 1, to the, in this case, 36th power, because it's 12 times 3. That gives me $478.67. All right, so let's try another one together. So we have an initial value of 10,000. We have a rate of 3.25. So when I make that into a decimal, it becomes 0.0325. It's going to be compounded quarterly. So that means 4 times a year. So I'm going to divide by 4. I'm also going to multiply by 4. My exponent is going to be 4 times the length of time, 40 years. So 4 times 40. So think of that. Over 40 years, 4 times a year, it's going to be calculated, or that interest is going to be compounded and grow 160 times. So I've got 10,000 times, and then in parentheses 1 plus 0.0325 divided by 4 to the 160th power. And over those 40 years, that $10,000 is going to grow to be $36,500.73. All right, hopefully that makes sense. I want you to go to these last 3 problems in your note packet, give those a try, and then I'll show you the answers here in just a moment. All right, if you haven't paused already, pause it, try these for yourself, and then when you're ready, go ahead and hit play, and then I'll show you the answers. All right, here are your answers for each one of them. We had 3.5%, which is 0.035 as a decimal. It was compounded monthly, so we had to divide by 12. But then we also multiplied the years times 12, because it's going to be done every 12 times each of those 3 years, and got my final answer. So check your answers, see if you got the right numbers in the right spots, and let me know if you have some questions.